This is lesson 12.4, normal distribution. Our objectives for today are to understand the normal distribution and skewed left or right, to recognize whether a data set is normally distributed or skewed, and then make conclusions or predictions about data sets based on their normal distribution. So one type of distribution commonly used in statistics is the normal distribution. It has data that vary randomly from the mean, and the graph of a normal distribution is called a normal curve. You can see one here. The curve is bell-shaped and is symmetric about the mean. So in normally distributed data, this is the mean right here, right in the center, and you can see that it's symmetric, okay? So normally distributed data is symmetric. If you happen to have skewed data, it's going to look asymmetric. So if you look at these pictures here, you'll see, so we call this one positively skewed. It seems kind of funny because it's like, right? The center is off to the left, but we call it positively skewed, so it's kind of funny, okay? So you have like a tail that looks different going in the positive direction, and negatively skewed, you have a tail coming off in the negative direction, all right? So when a data is skewed, it doesn't vary predictably from the mean, so you can't predict as well, right? All right. So let's do examples. With the new COVID-19 antibody test, scientists have noticed that the vast majority of people who test positive have few or no symptoms. So if you were to draw a bell curve, what would it look like? Would it be normal or skewed? So if we did number of symptoms, it said the vast majority of people have few or no. So if we did like less symptoms and more symptoms and we were to graph this, right? You know, the vast majority having less symptoms. So it's going to be skewed positive, right? Remember, the way that the funny tail goes, positive or negative, is the direction of the skew. With COVID-19, people with traditionally lower income jobs like grocery store workers and truck drivers are now highly in demand, while a lot of people with higher income jobs are laid off. How would this change the way the bell curve of income by job is skewed? So again, now you have lower income people now having more jobs and being better off than higher income people because of the layoffs. So it's going to skew it again positively. So assume you are going to collect data with every Lehigh High Schooler's fourth quarter grades with the new A, B, C, or PASS policy in place. Would this be normally distributed or skewed, right? So usually, traditionally in school systems, they actually used to force the data to be normally skewed, grading on the curve. When you have heard that, that's where this comes from. What it used to be is that C was in the center, and then you had D and F down here, B and A right here. And so they would actually take students and rank them top to bottom, right? And students who were in the middle were given C's. Only the very top students were given A's, only the very bottom students were given F. They would normally distribute the students' grades, right? So with this new ABC PASS policy, how is this going to affect this distribution, right? So now you have PASS down here instead, right? So now everybody that would have gotten D or F before are now getting a pass, so it's going to kind of skew it in this direction, right? Because more people will get this now because it's now these two combined, right? All right. So the rule of standard deviation, it says 65, 95, 99.7 rule. Okay, it says that's what people fall in. So this right here, the middle is always your mean. And then if you go down 1 standard deviation, you're here, go down 2 standard deviations, go down 3, see how it says? Down 1, down 2, down 3. Up 1 standard deviation, up 2, up 3. So that's how you calculate where people are along a normal curve, is by calculating how many standard deviations they are away from the mean, right? So if your data is normally distributed, 68. See how it's 34 on either side? So 68% of the data falls within plus or minus 1 standard deviation. And then if you add this up, 13.5 plus the 34, and the 13.5, 95% of people are falling within plus or minus 2 standard deviations. And then if you add all the rest, we get 99.7% fall within 3 standard deviations. Okay? Anything out beyond that is another definition for an outlier, right? Okay? So here's a problem. The body temperature of healthy adults is normally distributed with a mean of 98.6 degrees and a standard deviation of 0.6 degrees. Sketch a normal curve showing the body temperatures at 1, 2, and 3 standard deviations. All right. So we're just going to make our curve and put our mean in the middle. And then 1, 2, 3 standard deviations up, 1, 2, 3 standard deviations down. Now the standard deviation is 0.6, so it's pretty easy. All we have to do is add 0.6, right? And then add 0.6 again, and then add 0.6 again. Did I do that right? No, I think it's 100.4, sorry. Okay. And going this way, we're going to subtract the standard deviation. Whoops, 98.0, right? Whoops. That looks terrible. So it's 98. Let me fix that. Okay, and then we'll subtract 0.6 again and get 97.4. And subtract 0.6 again. And we get 96.8. Okay? So it means if you measured people's temperatures, right, the majority of them fall in here, right? 95% fall in here. 99.7% fall in here for a normal body temperature, and anybody above 100.4, anybody below 96.8 is an outlier. All right, a set of data has a normal distribution with a mean of 50 and a standard deviation of 8. Find the percent of data within each interval. Okay, so let's make a little curve here. It always helps to draw a picture. Standard deviation of 8, right? So I have 58, and then add 8 more. Whoops, 58. Add 8 more. And add 8 more. Okay. And then let's subtract 8. And subtract 8. And subtract 8. Okay. So the first one asks from 42 to 58. So it wants to know what people are here from 42 to 58. That's the 1 standard deviation away. That's the 68%. Right? Remember, it's 34 and 34 right here. Okay. Next, what's the percentage of people greater than 34? So here's 34, and we want everything up above. Okay, so if you remember, all right, so you think about it this way, everything from here on up is 50%, right? And then everything from here to here, this is that 34%. And then here we have the 13.5%. So we can add up 13.5 plus 34 plus 50 to find out greater than 34%, right? So I'm just going to type that in real quick. 13.5 plus 34 plus 50, and I get 97.5%. Okay, makes sense? All right, next one. The bar graph gives weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean of 115 kilograms. Approximately what percent of female brown bears weigh between 100 and 129 kilograms? So here I can see the 100 mark, and here's the 129 mark, right? So here is our middle. So it looks like 1, 2, and 3 standard deviations like this, right? So again, this is the same 68%, right? So approximately what percent of female brown bears weighs less than 120 kilograms? Okay, so here's the line for 120 right here. All right, so we want to go down. Okay, so here's your 68%. We're going below, right? So right here would be 50%, okay? So if we want to know this much, so this is the 34%, and then all the rest of this is 50%. So 34 plus 50. So 84%. All right, so if we want to decide if gathered data is normally distributed, we're going to check two things, right? You can make a bar graph just like we saw in the bear problem before, and see if the bar graph looks like a normal curve shape, or does it appear skewed in either direction. You can also check to see if the data fits the 68%, 95%, 99.7 rule, and see if it actually works, right? So you check if 68% of your data is within plus or minus 1 standard deviation of the mean. Okay, now you can make histograms on your Desmos calculator. This is pretty cool. Right, so I'm going to start out making a set. I'm just going to enter in some random numbers for this so I can show you how to make a histogram. So I'm just entering in a bunch of random numbers. Okay, good enough. All right, so over here in functions, we're going to go up to distributions, and you can see right here we have histogram. Histogram A. And again, you might have to slide your graph over to see the data. So like I had a minimum of 10, right? And there we go. There's our little histogram right there. So I can see that this one looks like it's skewed negatively a little bit, right? If I tried drawing in a normal curve over this data, it looks like it's skewed negatively. See that? Pretty cool, right? All right. So what you want to do is you want to find the standard deviations for the data and then check to see if it fits the empirical rule, right? See if 68% of your data happens to be within plus or minus 1. Check if 95% of your data happens to be within plus or minus 2. And check if 99.7% of your data is between plus or minus 3. It's kind of a pain to do, and unfortunately the calculator doesn't really do this part, but that's okay. All right. So here we have the average number of students by teacher who quit online school after the ABCP grading system was announced. So sad, you guys. All right, so I've already typed this in because it was so many elements. There's 50 numbers to type in, so I just typed it in ahead rather than making you sit here and watch me do this. All right, so first let's go in and make a histogram out of this data. So we can see with the histogram whether or not it looks normally distributed. All right, so it kind of does, right? It has a center. It might be a little bit skewed negatively because of this over here on this side. So let's check it and count, okay? All right. So what I'm going to do now is I'm going to come over here and I'm going to figure out what my mean is. So my mean is 17.28 there in the middle, and now I'm going to figure out what my standard deviation is. Okay? So there we go. All right, so now if I want to know what is one standard deviation away, whoops, sorry. So I can add that on. And then I can also subtract it off. Okay, so now what I can do is say, does 65% of my data fall within those two values, right? So I could go back to my original list and count it up. So now I'm going to take, oh, whoops. Hold on, messed up. I'm going to take those two values and add on another standard deviation. So now I'm 2 standard deviations, so 95% of the data needs to fall between those two numbers. And finally, I can take those two numbers and add and subtract one more standard deviation. Now I'm 3 standard deviations away, right? And 99.7% of the data needs to fall between those two numbers. All right, so now we could look at the original list and decide if the appropriate amount of data falls between each of those two numbers. All right, and that is it. That is the last lesson and the last video. I'm so proud of you guys, and it was wonderful to be your teacher next year. I hope to see you next year. Stop in and say hi to me, and thank you so much for participating in my class and watching all these videos. You guys are the best.